Imagine a machine so enormous that if it ever shut down deep underground, it could never be brought back to the surface. Not because it broke down, but because by then the mountain would have already closed in around it. When most people picture tunnel construction, they imagine explosions, jackhammers, or thousands of workers digging through solid rock for decades. But that's not how the world's toughest mountains are conquered. Today, they're pierced by a single mechanical giant. A machine so colossal it looks like something built for another planet. A machine that moves forward in complete darkness, surrounded by millions of tons of rock, unable to see the world outside, yet somehow always knowing exactly where it's going. Today, we're going inside the largest underground machines ever built by humanity. And once you see what they're capable of, you'll understand why many engineers say these machines don't just drill through the earth, they consume it. If you're fascinated by impossible engineering, record-breaking mega projects, and machines built on an unimaginable scale, make sure to subscribe and turn on notifications, because our next journey will take you even deeper into the world's greatest engineering marvels. To understand the true scale of a modern tunnel boring machine, you first have to forget everything you think you know about construction equipment. Our brains simply aren't wired to imagine something like this operating hundreds of meters beneath solid rock. Picture a 5-story building laid on its side, then bury it deep beneath a mountain with no natural light, no open space, and almost no room for error. That's a tunnel boring machine, a TBM. The largest models exceed 50 feet in diameter, large enough for a fully loaded truck to drive through while still leaving space for electrical systems, maintenance walkways, hydraulic equipment, and multiple working platforms. But even that doesn't capture its true scale. Some tunnel boring machines stretch nearly 500 feet in length, longer than an entire football field. Hidden beneath the surface, they crawl forward just centimeters at a time, while the world above carries on completely unaware. A single machine can weigh between 4,000 and 7,000 metric tons, combining massive steel structures, powerful hydraulic systems, advanced electronics, and thousands of moving components into one of the most sophisticated construction machines ever built. Step inside, and it feels less like a construction site than the control deck of a spacecraft. Hydraulic cylinders line the walls. Electrical cables run in every direction. Cooling systems, pumps, sensors, and flashing control panels surround the crew at every turn. There is no horizon, no daylight, and no sense of the outside world. Only steel, constant vibration, and the immense pressure of the mountain pressing in from every direction. After just a few minutes underground, it's easy to forget you're inside a machine at all, and then you reach the front. This is where the true power of a tunnel boring machine reveals itself. Dominating the nose of the machine is the cutter head, a gigantic rotating wheel fitted with hundreds of cutting discs made from ultra-durable tungsten carbide alloys. These discs are designed to survive conditions that would destroy conventional cutting tools in minutes, allowing the machine to grind through some of the hardest rock formations on Earth without stopping. But despite its enormous size, brute force isn't what makes the cutter head so effective. Unlike a household drill that punches straight through a surface, a TBM works through relentless, controlled pressure. As the cutter head slowly rotates, each cutting disc presses against the rock with tremendous hydraulic force, creating microscopic fractures that gradually spread until the rock finally breaks apart. Granite, one of the toughest natural materials on Earth, doesn't explode into pieces. It slowly gives way under continuous pressure, centimeter by centimeter, as the mountain is methodically dismantled from within. The sound inside the machine is unlike anything most people will ever experience. A deep mechanical roar echoes through the entire structure, vibrating the steel beneath your feet and resonating through every corridor. Over time, experienced crews become so familiar with that sound that they can often sense when something has changed long before a warning appears on a monitor. Underground, the machine develops its own rhythm, and learning to understand it becomes part of the job. Of course, carving through solid rock raises an obvious question. If this machine is chewing through thousands of tons of mountain, where does all that material actually go? Just behind the cutter head, the broken rock drops onto a continuous series of heavy-duty conveyor belts that carry it all the way back through the machine and out of the tunnel, hour after hour, day after day. This endless mechanical system removes enormous volumes of excavated rock without interrupting the advance. It's one of the key reasons modern tunnel construction is dramatically faster than it was only a few decades ago. Instead of stopping to clear debris, the TBM excavates and removes material at the same time, maintaining a steady, carefully controlled pace. And that's only when it's cutting through solid rock, because mountains, surprisingly, are often the easy part. The real challenge begins when the machine must pass beneath rivers, soft ground, skyscrapers, or densely populated cities, where even the slightest movement at the surface could have serious consequences. Passing through solid rock is challenging enough, but modern tunnel boring machines are expected to do far more than that. Many projects require them to excavate beneath rivers, highways, skyscrapers, and entire neighborhoods, where even the smallest ground movement could damage buildings above. In these environments, raw power alone isn't enough. The machine has to become incredibly precise, maintaining complete control over the ground while it continues moving forward. To accomplish this, many TBMs use an earth pressure balance system, or EPB. Instead of simply cutting into the ground, the machine carefully controls the pressure at the excavation face, preventing the surrounding soil from collapsing. Depending on the conditions, specialized foam and conditioning agents are mixed with the excavated material to create a stable, pressurized barrier in front of the cutter head. It's an elegant solution to one of underground construction's biggest challenges, holding the ground in place while removing it at the same time. The result is almost unbelievable. A machine powerful enough to carve through mountains can also pass beneath a busy city with little or no visible impact at street level. Cars continue driving, trains stay on schedule, office buildings remain full of people who have no idea that hundreds of feet below them, one of the largest machines ever built is quietly reshaping the world beneath their feet. Few engineering achievements combine such immense power with such extraordinary precision. But carving a tunnel is only half the challenge. Once the machine disappears into complete darkness, it faces another problem that's even harder to solve. How do you navigate through miles of solid rock when you can't see anything? There are no windows, no landmarks, no GPS. Deep underground, every direction looks exactly the same. Yet somehow, these machines can travel for miles and arrive at a target with astonishing accuracy. The answer lies in a guidance system so precise that it feels almost impossible. High-precision laser stations establish an invisible reference line that runs through the tunnel, constantly tracking the TBM's position. As the machine advances, onboard computers monitor its alignment in real time. If it drifts even slightly off course, hydraulic cylinders automatically make tiny corrections, steering thousands of tons of machinery back onto the planned path without interrupting the excavation. Most of these adjustments are so small that the crew never even notices they're happening. Laser guidance is only part of the equation. Modern TBMs are also equipped with geological monitoring systems that analyze the ground ahead of the cutter head, helping engineers identify unstable rock, underground water, or changing geological conditions before the machine reaches them. That information allows crews to adapt their excavation strategy long before a potential problem becomes a serious threat. The accuracy achieved by these systems is extraordinary. In some of the world's largest tunneling projects, two tunnel boring machines have started from opposite ends of the same mountain, separated by miles of solid rock, and met almost perfectly in the middle. One of the best-known examples is the Channel Tunnel, where tunneling teams advancing from England and France achieved a level of precision that would have seemed impossible only a few decades earlier. It's a remarkable thought. Flying a spacecraft through deep space requires incredible navigation, yet these machines perform a similar feat while buried beneath thousands of feet of solid rock, relying entirely on engineering, mathematics, and precision surveying. And for the people operating them, this level of accuracy isn't extraordinary anymore. It's simply part of another day's work underground. Then, just when you think the engineering can't become any more impressive, the machine begins building the tunnel behind itself. As incredible as the excavation process is, the real genius of a tunnel boring machine is that it doesn't wait until the end to build the tunnel. It constructs the permanent structure as it moves forward. While the cutter head continues grinding through rock, another operation unfolds just a few yards behind it, where an entire underground factory works in perfect synchronization without ever slowing the machine down. At the center of this process is a massive robotic arm known as the erector. Its job is to lift enormous precast concrete segments, each weighing several tons, and place them with incredible precision. Delivered by supply trains running through the machine itself, the segments are installed one by one until they form a perfect concrete ring around the freshly excavated tunnel. Every piece has to fit flawlessly because that ring immediately becomes the tunnel's permanent wall. Once the ring is complete, powerful hydraulic cylinders push the entire machine forward by bracing against the newly installed lining. As it advances, a special grout is injected into the narrow space between the concrete and the surrounding rock, filling every gap and locking the tunnel securely into place. By the time the cutter head has moved only a few more feet, another complete section of tunnel has already been finished behind it. That's what makes these machines so revolutionary. They don't just excavate, they build. Instead of leaving behind an unstable cavity that must be reinforced later, a TBM continuously transforms solid rock into a finished tunnel ready for tracks, utilities, or highways. Every foot of progress is immediately converted into permanent infrastructure. This level of automation has made projects possible that would have seemed unimaginable only a few decades ago. The Gotthard Base Tunnel in Switzerland, for example, pushed these machines to their limits as they excavated beneath thousands of feet of alpine rock. Projects that once demanded decades of dangerous manual labor can now be completed in just a few years thanks to the combination of robotics, precision engineering, and relentless mechanical endurance. Yet even with all this automation, none of it would work without the people inside. Behind every tunnel boring machine is a team of engineers, mechanics, electricians, surveyors, and operators who spend long shifts deep underground, keeping one of the world's most complex machines running around the clock. For them, entering a TBM feels less like arriving at a construction site and more like boarding a submarine that travels through solid rock instead of water. Once the machine is operating, the outside world quickly disappears. There are no windows, no sunlight, and no easy way out. Steel corridors, artificial lighting, constant vibration, and the endless roar of machinery become everyday life. Underground, the crew depends entirely on the machine and on each other. A single mechanical failure or an unexpected geological problem can affect the progress of the entire operation, making teamwork just as important as the technology itself. From the control room, operators monitor everything in real time. Hydraulic pressure, cutter head performance, machine alignment, temperatures, conveyor systems, and the condition of hundreds of cutting discs at the front of the machine. It's a workspace that looks far closer to a spacecraft's control center than a traditional construction site, with screens, sensors, cameras, and live data constantly flowing in from every part of the machine. The environment is anything but comfortable. Temperatures can climb above 100 degrees Fahrenheit, while humidity, dust, vibration, and the constant rumble of steel against rock never truly disappear. During projects like the Riyadh Metro, where several of the world's most advanced TBMs operated simultaneously beneath the desert, keeping both the machines and their crews cool became almost as challenging as the excavation itself. After spending thousands of hours underground, experienced crews begin to develop an almost instinctive connection with the machine. They learn to recognize subtle changes in sound and vibration long before alarms appear on a screen. In many ways, they're underground astronauts, working in one of the most isolated and unforgiving environments on Earth, relying on engineering, discipline, and one another to keep moving forward. While these underground giants spend their entire lives hidden beneath mountains and cities, there's another machine that represents the opposite extreme. It doesn't work in darkness. It doesn't disappear underground. Instead, it dominates the landscape in plain sight. It's called Bagger 293, and it's one of the largest land vehicles ever built. Standing more than 300 feet tall, stretching nearly 740 feet long, and weighing over 14,000 tons, Bagger 293 is so enormous that it requires its own dedicated power supply just to operate. Its massive bucket wheel strips away entire layers of earth as it crawls across open-pit mines, moving with the same slow, deliberate pace as a tunnel boring machine, but under the open sky instead of beneath solid rock. At first glance, these machines couldn't look more different. One tears away mountains from above, the other slips silently through them from below. One is impossible to miss. The other can spend years working beneath a major city without most people ever realizing it's there. Yet both were created to solve the same problem, moving unimaginable amounts of earth with extraordinary precision. And that's what makes them so remarkable. They're not simply bigger excavators. They're machines that forced engineers to rethink what was physically possible. Every new generation pushes the limits a little further, becoming faster, smarter, more efficient, and more accurate than the one before. Projects like HS2 in the United Kingdom continue driving that evolution, proving that underground construction is still advancing at an astonishing pace. But the future of tunnel boring machines may extend far beyond our own planet. Engineers have already explored concepts for autonomous tunneling systems capable of operating on the Moon or Mars, where excavating beneath the surface could one day protect astronauts from radiation, meteorite impacts, and extreme temperatures. The same technology that now carves tunnels beneath our cities could eventually help build humanity's first underground habitats on another world. There's one final detail, though, that most people never hear about. When a tunnel boring machine completes its mission, it doesn't always come home. Recovering something this large isn't always practical, so in many projects, sections of the machine are simply left behind, sealed inside the finished tunnel. After years of grinding through solid rock, these engineering giants remain exactly where they finished their work, silent, motionless, and forgotten beneath the surface. It's a fitting ending for machines that spend their entire lives out of sight. Millions of people travel through the tunnels they created every single day without ever realizing that just beyond the concrete walls, pieces of those colossal machines may still be resting in the darkness where they completed their final journey. And maybe that's the most fascinating part of all. The greatest engineering achievements aren't always the tallest skyscrapers or the longest bridges. Sometimes they're completely invisible, hidden beneath our feet, quietly transforming the world in ways most of us never stop to think about. The next time you ride a subway, drive through a mountain tunnel, or cross beneath a river, remember that none of it happened by chance. Somewhere below the surface, one of the most extraordinary machines ever built slowly carved that path through solid rock, 1 foot at a time. If you enjoyed this journey into the hidden world of underground engineering, let us know in the comments. Here's a question for you. Would you spend weeks working inside one of these incredible machines? Why? Or why not? If you're fascinated by mega projects, massive machines, and the engineering that continues to reshape our world, make sure to subscribe and join us for the next journey into another incredible feat of human ingenuity. Thanks for watching, and we'll see you in the next Colossal Scale.